Another useful factoring strategy is factoring by grouping. So sometimes I don't have a greatest common factor that's in common with all of the terms in my expression. In this case, this one doesn't have an x or a y, so I can tell I'm not going to be able to factor any variables out of all four. And this doesn't have any constants bigger than 1, so I'm not going to be able to factor any constants out of the whole thing. So there isn't a greatest common factor, but there are still things I can do to factor this. I'm going to factor by grouping it into some smaller expressions with only 2 terms, and try to factor things out of just those. So if I look at just these first 2 terms and don't think about my second 2 terms, I can find a common factor among those 2 terms. They each have an x. I have x times y plus 2 times x. So even though I couldn't factor an x out of those, I'm making progress on this half, and I can factor that x on out and get x times y plus 2. And then I can go over here and look at these 2 terms. Well, I can't factor a y out of both of them because this just has a constant, but 6 is the same as 2 times 3. So I could write this as 3 times y plus 3 times 2, and then I would have a common factor of 3 that I could factor out of each of those terms. And here, something cool happened. Now I have x times y plus 2 plus 3 times y plus 2. So I have a common factor here of 3 times 2. Sorry, y times 2. So this is a common factor, and I can factor it out of each of those terms and get y plus 2. And I'm left with this x from over here plus this 3 from over here. And so I have now factored this expression by grouping. I grouped it into two-term expressions that I was able to factor something out. And since luckily I ended up with the same factor each time, I could then factor that out. And I have now factored this into a multiplication problem. And if I multiplied this out, I would get my original expression back. Let's do a few more examples. I have 2xy minus 8x plus 5y minus 20. I can use my grouping strategy again. I really want there to be a GCF here because this one, and this one all share a 2. But 5 remains very much not divisible by 2. We ignore the fact that we could have fractions. I could make that 2.5 if I divided it by 2. We're not doing that. We don't want fractions right now. That's just not a thing we're doing. We're going to keep it all as integers. So I can't find a constant GCF. This doesn't have a variable, so I don't have a variable GCF. But I can still use my grouping strategy. If I look at just those two, I can factor out definitely an x, and since they're both even, I can factor out a 2. And since this is a 2, I know I can't factor out anything bigger than 2. So I have 2 times x times y minus 2 times 4. 4 should not be color-coded that way, my apologies. Times x. And I have a 2 and an x in each of these, so I can factor out that 2x and bring it out in front of my multiplication problem. And what I'm left with in there is y minus 4. And then we'll see if I can use that strategy again with my other two terms and get the same y minus 4 when I'm done. Well, when I look at these, I can't factor out a y because that doesn't have a y. But I can factor out a 5 because that's 5, and 20 is 4 times 5. So I have 5 times y minus 5 times 4. So then I can pull that 5 out of each thing. And get 5 y minus 4. And then, since now I have two things that are each multiplied by y minus 4, this is multiplied by y minus 4, and this term is also being multiplied by y minus 4, I can factor a y minus 4 out of each of those terms. And I get y minus 4. And then what's left, after I've factored that y minus 4 out of each of these, is 2x plus 5. And then I've rewritten this as a multiplication problem. I've factored this polynomial. I could multiply it out and I would get the original thing back. I'm going to do 2 more examples. I have x to the third minus 3x squared plus x minus 3. I can use the same strategy. I could factor an x out of all 3 of these terms, but if I did that, I'd have unequal sizes in my parentheses after I was done factoring, and then I wouldn't be able to factor anything out in the next step. So rather than that, I'm still going to split it evenly into 2 groups. In this group, I can factor out, definitely there's an x. There's actually an x squared in each of these, because x to the third is like x squared times x. So this one would have x squared times x minus 3 x squared. And then I can factor that x squared out of each of those terms. And I get x squared, and then inside my parentheses, I'll be left with x minus 3. Then over here in my other term, I've already got x minus 3. But I need something to factor out. There's nothing in common there. Well, this is when it's actually useful to factor out a 1. This could be 1 times x minus 1 times 3, just because I'm going to want that placeholder 1, because I'm going to need to be able to factor this out of 2 different things in this step. So I factor the 1 out, because multiplying by 1 doesn't change anything. So I could always factor a 1 out. It's just the vast majority of the time that isn't actually helpful. X minus 3. So now I have each of them as x minus 3 multiplied by something, in this case by x squared, in this case by 1. So I can pull my x minus 3 that matches out and put it in front. X minus 3. I can get the rest of my parentheses assembled here. X squared plus 1. And that's why I needed the 1, is so I had something to put there. Because that's what I need to do so that when I multiply this whole thing through, I'll get all 4 terms. If I just multiplied this by x squared, I'd end up with x's in all of the terms. And this 1 needs to get multiplied by the negative 3 so that I can have that negative 3 term. I'm going to do one more example, and then I'll end the video. So with this one, you may have already noticed a real pattern in these numbers. Each of our terms has a constant term where the last digit is 5. And if you know your 5's multiplication patterns, that means you know these are all divisible by 5. So that means this one does have a GCF. It has a GCF of 5. So before I tackle factoring by grouping, I'm going to go ahead and pull that GCF out just so that everything else will be smaller. So I'll have 5 times xy minus 35 is 5 times 7. 5 times 7x minus 5y plus 5 times 7. And I knew there wasn't any kind of variable to pull out with this GCF because this didn't have a variable. And since I'm grabbing the entire constant from these, I knew it wasn't going to be anything larger than 5. But now I can pull that GCF on out and then spend the rest of the time ignoring it. And that gives me smaller numbers to think about the rest of the time and reduces my mental load. Now I can focus on this smaller polynomial and factor it by grouping. The 5 will just be along for the ride the rest of the way. In this case, here's my first group, and all I can factor out of this is an x. I'd have x times y minus 7 times x. So 5 x y minus 7. Now let's tackle this. I already know my goal is to get this to be y minus 7, and right now it's minus y plus 7. So I'm going to do something kind of weird. I'm going to factor, a negative 1 out of each of these, because this could be plus negative 1 y plus negative 1 times negative 7. That's allowed. It feels kind of complicated, but what it does is it lets me grab a y and a negative 7 so that it'll match. So here, I can grab my negative 1s. Negative 1. And that leaves me with either y plus negative 7 or y minus 7, because those are the same thing. So now my 5 is still along for the ride. And I can factor this y minus 7 out of each of those terms and put it right here. Y minus 7. And then I'm left with x minus 1. And that is my completely factored expression. I factored out a GCF, and then I factored by grouping with each of my parts. And then I ended up with this as my factored expression. I have a lot of practice doing this, so I'm pretty good at seeing that like 35 is 5 times 7. If you're still struggling with having your multiplication tables memorized, having a printed multiplication table so you can look and find 35 in the middle of the table and then go see, oh, that's this times this, may be a really useful tool while you work on this, because it can let you see those factors. It's mostly a matter of practice, and you'll get better at it the more you do it. That's all for this video, and I'll see you in the next one.